Ecco qua. Oggi mi sono riconnesso, mi senti bene? Mi vedi?
Ti sentiamo?
Sì?
Sì, perfetto.
No? Quando iniziamo?
Ci darà il via Giulio.
Sì, a momenti. Sto parlando con Damiano e appena ci siamo partiamo. Ok, Francesca.
Sì?
Ho ricevuto l'ok da Damiano, lo streaming è attivo, quindi potete tranquillamente cominciare.
Ok,
Per qualsiasi cosa sono qua.
perfetto. Good afternoon, ladies and gentlemen. Thank you for coming today. I'm Francesca Maltinti, and today I work at the University of Cagliari, and I am pleased to introduce this session. I remind everyone you have got a maximum 15 minutes each for presentation and 5 minutes for question. But let's open immediately with the first presenter. He is James Romby. James holds a Master of Science in Environmental Engineering and a PhD in Structural Engineering. At the University of Cagliari, he studies innovative materials for road pavement layers. He also researches sensors for installation within various pavement layers to monitor their behavior under real working conditions. Additionally, he studies life cycle assessment and environmental product declarations for the potential application of byproducts in pavement. Please, James, the floor is yours.
Thank you very much, Mr. Chairman. Can you hear me?
Yes.
Okay. I'll just put my presentation. Okay. Can you see my presentation?
Not yet, James.
What about now?
Not yet. We can see your
My image.
directory. No,
Okay.
now the room.
If it can be of help, maybe you could start first the presentation in full screen mode and then share the screen.
Go. Okay. And now?
Not yet.
Okay. Now it's okay, James.
Okay. Is it
try
fine?
to put it in full screen mode.
Is it on full screen mode?
Not yet.
No.
Okay.
If you have got a single monitor set up,
Yes.
it's enough to share the full screen. So when you click on sharing, you can also select the entire screen option, and then it will work.
Okay,
Perfect.
James.
Okay.
Okay.
Thank you very much, Mr. Chairman, for the presentation. So the title of this presentation is Experimental Campaign on the Application of Fast Falling Weight Deflectometer for Possible Rapid Bridge Conditioning Monitoring. Before I start my presentation, I would like to acknowledge my colleagues that have worked with me at this research. There are Marta Salis, Francesca Maltinti, and Mauro Coni. We are all of the Department of Civil and Environmental Engineering of Architecture of the University of Cagliari. The following slides of this presentation are going to follow some issues that we have during this research. There will be a short introduction. I will talk about the aims of this research, then the case study, tests conducted and data analysis, conclusions, and finally potential applications and future studies. As we know, bridge monitoring is essential to ensure safety and longevity of the infrastructure. There are various methods that are used to employ and to assess the bridge vulnerability, but some are not very expensive, and in some cases they're not very easy to perform when you have to leave the roads open. So factors such as fatigue, corrosion, reinforcement, and aging are crucial to evaluate the residual life of bridge structures. Normally, the first inspection that we do is the visual inspection, that it's simple, low cost, and commonly used. But in many cases, it's not always adequate. And in some cases, you can't always find some critical information that can help you to evaluate the vulnerability of the structure. As we know, in 2018, there's been a large collapse with the Morandi Bridge in Italy that prompted significant call to improve monitoring in road infrastructure. This triggered a widespread attention for the formulation of specific guidelines by the Italian Ministry of Infrastructure and Transportation. On the basis of these informations and what happened, we thought to develop a non-destructive and rapid, repeatable, over time, efficient system using the fast falling weight deflectometer to perform tests on reinforced concrete bridges. As we know, fast falling weight is a system, non-destructive measuring system used normally in pavement in the field of rigid, semi-rigid, and flexible pavement to evaluate the bridge's stiffness, to evaluate the pavement stresses across various types of reinforced materials. In this research, we use it to predict and measure the stiffness on concrete bridges divided in single span and multiple span bridges. So let's go to the case study. The testing campaign was conducted on 8 reinforced concrete bridges located on the southern region of Sardinia. You can see here on this pictures the location of each bridge that has been tested. They are all in the province near Cagliari on the southeast of Sardinia. On your right, you can see a table when there is the bridge type, the 8 bridges, and some geographical information, the length and the width. Also additional information that are useful, or that were useful for us to locate exactly where the bridge was, because these are bridges all located in roads, and some bridges were overpass, arch bridges on railways. So we had 2 big families, multiple span bridges, there were 4, and other 4 single span bridges, divided in single span and arch bridges. So, before performing the test campaign, a schematic grid of testing point was established for each bridge, taking into account the geometrical structure. As we can see in this chart, this is one of the bridges that we tested. There is a total of 45 testing points. The circle that you see in different colors, it's where the falling weight perform its tests. So we've got the circles marked in purple, they are performed on the deck. Then we got the red in correspondence of the beams, and the green ones are those tests performed on the approach ramp. For each bridge, this was done. So once you go to perform the test, you know exactly where to position the falling weight deflectometer. So let's introduce the falling weight deflectometer. As you can see in this figure, is this instrument here. Is towed by a vehicle and is all instrumented. On this side, on the back side, you can see here where the system has its weights. It performs a dropping weights on the surface from a specific height, and with gyrophones we are able to measure the speed and the extent of the deformation on the pavement. In this case, on the bridge structure. To better understand how it works, we see here this short demonstration. The falling weight goes into position on the element that we need to test. We load the bars with the gyrophones. The weight rises, and then it drops. The gyrophones capture the deflection balls. We must say that in this testing case study, we use in total 12 gyrophones. Then you rise the plate and you're ready to go to the next point. All this procedure lasts approximately less than 1 minute. So it's very fast testing procedure. So let's see the data analysis. I must say that it is in just the beginning of this research. So we've got many data to analyze. This is what we analyze first. So the methodology employed the analysis of the stiffness value obtained from the ratio between the maximum load applied and the maximum deflation. When we did testing, we did 4 increasing vertical stress levels. We performed first 900 kilopascal, 1200, and finally 1600. On the basis of this result, we measured the maximum deflection that is measured by the geophone D0 that is positioned underneath the plate load. Here we see the first data analysis on the first 4 bridges. I must remind you that the first 4 bridges are those with multiple span. We can see the values obtained for the beam, the deck, and the approach ramp. Also, we measured not only these values, but we measured overall the standard deviation between these values. As we can see, the maximum stiffness was obtained by measuring the beam, and the lowest was on the approach ramp, but that is expected because the approach ramp is not made of concrete, but it's a normal layer with bitumen and a foundation with granular materials. So it was just to see how the data that we could vary in measuring different types of materials. The second lot of tests was that performed on the other remaining 4 bridges. The remaining 4 bridges were single span bridges. As you can see in this chart, we have 2 different behaviors. The first 2, number 5 and number 6, are arch bridges, and they behave totally different in respect to the other 2 bridges that are single span bridges. They all 4 are all 4 are overpass railway bridges. Due to that different behavior, we focus the attention on verify each testing point. Here we got an example on one bridge that we've tested. One thing that I didn't say is on each bridge we perform tests on the left, on the right of flow of traffic, and always also on the center line when this was possible. So we can see here railway overpass arch bridges. We can see that on the center of the deck they have a higher values of stiffness if we compare them with the single span normal bridges, in which they behave completely different. In conclusion, from these first initial sets of tests, we can say that the falling weight deflectometer has the potential to monitor bridges and viaducts. It can be considered as a possible test system. The test can monitor changes in deflection basin and stiffness over time, providing insights on how aging or other factors affect structures. Comparing multiple span bridges to single span ones clearly shows that multiple span bridges display greater variability in stiffness values across each tested element. Specifically, multiple span bridges exhibit higher stiffness values in the beams, while the deck and the approach ram indicate lower values, with the approach ram displaying the lowest values in minimal variability. However, single span bridges display different behavior. In the case of the 2 single span arch bridges, stiffness values are higher in the central portion of the deck, while they are lower on the left and right side. And then, finally, the potential applications and future studies. Further examination of the acquired data is important to gain a deeper understanding of the behavior of the tested bridges. This involves analyzing not only the obtained stiffness value, but also, very important, assessing the linearity behavior to identify any notable structural degradations. Due to the complexity of the bridge structure's behavior, it is crucial to broaden our scope by conducting multiple testing across a diverse range of bridge types. This will enable us to better understand not only the data that we are gathering from the falling weight deflectometer, but also have a wide range of application in multiple bridges. And then I thank you very much for the attention.
Thank you, James. We have some minutes for questions, comments for James. Mauro?
Thank you, Francesca. Can you hear me?
Yes.
Yes.
No.
Yes.
Let me compliment with James and all of us for this very interesting investigation. And it seems quite promising as far as structural health monitoring is concerned. And figure out that perhaps in the future development of your research, you are also thinking about developing some digital twin that can help you in interpreting the data provided by the falling weight deflectometer. Can you at least confirm this, or have you a different idea?
No, the idea is correct. At the moment, it was just the beginning because with the falling weight, you get a lot of data. So in this first phase, you can see that we only analyze the deflection basin of the higher impulse that we gave. But also we got all the other data, that is the 9,000 or 900 kilopascal and 1,000, because we always, like you do in road pavements, you give 3 loads of stresses. In this case, we only measured the last one, the highest, but we got all the other data. And another thing that we are promising to do, we would like to widen our sampling window. At the moment, our sampling window, we are using the 60 milliseconds window. That's the normal window that you use on road pavements. But I guess we are losing a lot of data. And so if we open up that window, we will see also how, especially if we got larger deck, how the deck is behaving.
Another tricking issue I may highlight is the presence and the interaction with the pavement.
Yes.
That is quite complex.
Yes, that's
obviously something that you have to take into account.
No, that's we know that problem, but it's got. We are trying to develop another system on it to evaluate what can be the deformation of the bitumen layer in respect of the deck of the concrete layer. That is the important thing that we need to understand better. So yes, that's another issue that we intend to analyze better.
Thank you very much.
You're welcome.
Thank you, James. Thank you, Mauro. So we can go on. The second presenter is Mauro Coni. Mauro received his Master of Science degree in Civil Engineering, the PhD degrees in Mechanical Engineering in 1995, and the PhD Fellow in Transport Infrastructures in 1999. He is a consultant for public administrations, airports, and private companies over the last 3 decades. From 2011 to 2016, he was a transport counselor for Cagliari administration. He is currently an associate professor of roads, railways, and airport at the University of Cagliari. He has authored more than 150 scientific papers which include the environmental impact of transport infrastructures, noise and vibrations, pavement simulation and design, materials, construction, maintenance and recycling, railway and road design. Please, Mauro, the floor is yours.
Thank you, Francesca. I share my presentation. Can you see my presentation?
Yes, Mauro is okay.
Okay, thank you everyone. Good afternoon. My name is Mauro Coni. I'm going to present you an investigation on utility cut patching co-authored by Silvia Portas, James Rombi, Paolo Mereu, and Francesca Maltinti. Utility cut patching, UCP, typical involves cut road payment, subsurface excavation, and patching work related to utility pipeline maintenance. The issue is important for urban areas where municipalities report an increasing cost, reduction of safety, and traffic flow efficiency. Also, UCPs affect user cost and comfort. UCP disrupt the static behavior of the pavement, producing cracking, permeability, and fraction deterioration. Structural strength, stiffness, durability, and reliability decrease, while deformation and dynamic load increase. Despite the importance of the UCPs for the infrastructure maintenance, there is a critical lack of quality control in their execution, resulting in rapid deterioration of pavement in few years. These reasons have led many road authorities to investigate how to control and reduce the impact of UCP on pavement. In the paper, we present a case study of bidirectional urban road where a water pipeline has been constructed in 2019 in one of the two lanes. The bituminous pavement was cut to a width of 70 centimeters and depth of 100 centimeters to install the water pipeline. The filling substrate material was the same of the excavated, and no information are available about its compaction. After that, the pavement was restored with the same thickness and material. The effect of UPC was investigated using in situ non-destructive fully weight deflectometer, comparing the structural quality of pavement where UPC and without UPC. As the preview presenter James showed, the fast fully weight deflectometer generate a sinusoidal impulse of 30 milliseconds on the window of 60 milliseconds and load a circular plate of 30 centimeters with higher resolution. The test was repeated 3 times, and in the analysis we refer to the largest impulse corresponding to about 9 tons on the plate load. From the formation, it's possible to evaluate the stiffness of the material of the underlying layers through Bay calculation technique. A total of 220 drop tests have been conducted along 3.8 kilometers of the road, and the graph show how the pavement subject to UCPs increased its deformability. On the left, we have the test outside UCP, and in the center, we can see the all deflection basin where UCP was installed. Of course, the graph shows how the pavement subject to UCPs increases its deformability with less homogeneity, a high variable coefficient. The average value of maximum deflection is 507 microstrain in the pavement without UCPs, while in the one with UCP, the value increased to 632 microstrain with a 25% increase. This graph shows clearly the greater variability of the pavement with UCP. The orange line is related to UCP pavement. From measurement, we can evaluate the basin index, a fast index correlated with the deformability of mixed asphalt, granular, and subgrade layer. You can see how the basin layer index related to hot mixed asphalt increased for about 150 microstrain to 180 microstrain, plus 16%. The same behavior for the other material. After that, the pavement simulation was validated using the average material modulus estimate from by calculation and fully weight deflectometer test, matching the same typical deflection shape. The finite length model was added with a rectangular cut, vertical rectangular cut, filled with the original material. The interface between all the new material was modeled also to take into account not perfect coupling all the new material. For the field and its interface were reduced for that reason. This figure shows the distribution of stress and the formation components in the modified model, assuming a load located above the left joint of UCP. Of course, the response depends on the position of the load. For this reason, one of the aims of the finite element simulation was to assess the effect of the load position relative to UCP. For this reason, the load represented by circular plate load with 6 tons was located at different distance from the border of the model, derived the profile below the load axis of displacement component, horizontal stress, horizontal and vertical deformation. And this is the sum result. The maximum deflection, about half millimeter, occur when the load is located at the center of the UCP. Values very close to this are also observed for load position outside of UCP in a large range around the UCP. The maximum values of horizontal tensile stress about 0.14 megapascals occur in the granular foundation where the load is located outside the UCP. Similarly, horizontal deformation results in tension at the base of the asphalt when the load is placed at the border of UCP with a value about 150 microstrain. Lower values are obtained when the load is located at the center of UCP. Finally, vertical deformation reach maximum value about 350 microstrain where the load is centered above the cap. In conclusion, the paper highlights the need for management system to address UCP-related issue by employing fully weight deflection test and finite element simulation. Results indicate increasing pavement deformability and variability due to the UCP affecting pavement performance and reliability. Finally, we perform a systematic literature review, conduct according to PRISMA methodology, return more than 250 relevant studies of UCP, and in this survey we can identify some key factors influencing UCP and the future research direction. Thank you. If you have any question.
Thank you, Mauro. If somebody has some, okay, Mauro D'Apuzzo.
Sorry, but it sounds me natural, you know, to interact with some friends.
It's good, Mauro.
We appreciate the question, Mauro.
It's very, I do have to compliment also with Mauro with this very excellent work, exploratory work on UCP. That is a very critical issue in a municipal area, indeed. I'm just thinking about if you are planning to, you know, studying alternative cutting layout that aimed at reducing the stiffness differential between the UCP area and the outside UCP area.
This is correct. There are some papers that face the problem. Some propose the trapezual cut to
or stepped, perhaps stepped.
Stepped, not also stepped, but trapetional, inverted trapetional. Of course, for the companies, for the work is more difficult. I think that the critical issue is the control. In the authorities, not also in Italy, in many people, they point out that the very poor control after the work. For a lot of reasons. For this, for that, the Federal Highway Administration right just the last year guidelines, very interesting, and also we are trying to import the guideline for our Italian municipalities. I think is very important because the damage of the work of utility cut is very high, and the cost and the maintenance and the safety is very reduced about that.
Thank you very much, Mauro.
Thank you, Mauro. Bye.
Thank you. Any other questions? No more. So we can go on. Our next presenter is Mauro D'Apuzzo, Associate Professor at the University of Cassino, Southern Lazio. Mauro, I would give you the floor immediately so you can tell us something about your research interest and your presentation, obviously.
Thank you very much. I'm sharing my screen, hopefully. Okay. And then, can you see my presentation?
Yes, everything is okay, Mauro.
Okay. Thank you very much. The title of the presentation is Towards the Development of Injury Metrics, Preliminary Analysis through Multi-Body Codes for a Vulnerable User. Before commencing, let me thank my co-authors, Engineering Giuseppe Cappelli and Sofia Nardoianni, that are the member of the research team on highway, railway and airport design operating at University of Cassino, and Vittorio Nicolosi, that is a professor at University of Rome Tor Vergata. Let me also thank what you see in whose logo is reported just right in the left position upward. It is most. What is most? Most is the Italian National Center for Sustainable Mobility. It is a very huge research efforts involving 25 Italian university and 24 public private company, all devoted to research on sustainable mobility. And this research is is partly funded by MOST. The outline is obviously a brief background on safety of vulnerable user, description of the method employed, results obtained, and conclusion. Let me show you some very little short figure on vulnerable users road safety issue in Europe. Obviously, there is an increase in concern on safety involving vulnerable user due to the widespread of new tools and the increase of sustainable mobility, especially in municipality, in municipal area. So there is a higher interest on safety regarding pedestrian, cyclist, and e-scooter rider. We are starting a research program, long-term research program, in which we want to obviously develop some sort of risk-based method to analyze safety issue concerning vulnerable user. And as you certainly know, risk is a stochastic entity that can be described as the product of three factors: the hazard, vulnerability, and exposure, if we consider a conventional approach that is usually employed in evaluating, for example, seismic risk. Okay, so the hazard is the probability to have a specific earthquake of a defined magnitude. Vulnerability is the conditional probability of have some defined damage threshold on buildings, for example, once that a specific magnitude earthquake has occurred. And exposure is obviously the conditional probability that some people will die following this aforementioned condition. But if we have to consider road safety, we need to somehow swap this factor. If we consider safety, we need firstly to evaluate the exposure, that is the probability. For example, if we are taking into account scenario involving pedestrian and vehicle, the probability that a vehicle will encounter the a pedestrian crossing the road, the conditional probability that an accident will occur once that a pedestrian is crossing while a vehicle is traveling. And finally, conditional probability that once that the accident has occurred, a specific injury level will be reported or will be suffered from, for example, pedestrian. So as you can see, there is a swap in this factor contributing to the risk. Method. We want to explore the use of multi-body accident reconstruction tools that are currently used in evaluating, obviously, liability in accidents in order to study different scenarios involving vulnerable user. But to use these simulation tools, we need firstly to calibrate these tools. So we follow two paths that you can see here. A first path devoted to the calibration of this software by comparing the results provided by this software, by these simulation tools, with some more refined simulation tools in order to have a good reliability of these simulation tools. And then we perform a first experimental, we may say, design of crash scenario involving some vulnerable user. The first part is devoted to the calibration, and we just looked through scientific literature, and we found very few papers involving simulation of e-scooter with the vehicle. And we picked this specific scientific paper dealing with this simulation scenario. According to this paper, 4 different impact scenarios were simulated. The first one is a lateral impact on the bonnet of the vehicle. The second and the third one is a lateral impact on the B-pillar of the vehicle. The B-pillar, I want to just remind you, is the vertical frame dividing the two side door of the vehicle. So it's a very stiff element in the lateral surface of the vehicle. That's why we consider also this scenario. The difference between these two scenarios is related to the layout of the e-scooter rider. In the B scenario, the layout of the body of the scooter rider is upright, whereas in the third scenario, the body of the e-scooter rider is leaning forward, trying to simulate some sort of evasive maneuver such as a braking maneuver. And finally, the fourth scenario is a frontal impact. Okay, so we have the head acceleration, the head acceleration time history according to the fourth scenario, investigated by using these multi-body accident reconstruction simulation tools. And we compare this peak acceleration, head acceleration value with those provided by the scientific literature. What's the difference? In the scientific literature was used a very general purpose simulation tools that is named MADIMO, and as most of you already know, MADIMO is a very famous tools that use in road safety and in automotive safety, because is able to take into account the stiffness and therefore the deformability of the surface that came into contact during the impact. Whereas in the simulation tools that we used, this is not possible. And obviously this will imply a lower computational cost. So as you can see, for most of the scenario investigated, the comparison is somehow satisfying. The only point, that is the red one, that is very different, is that related to the bonnet impact. Since in MADIMO the bonnet is obviously deformable, whereas in the simulation tool that we used, the virtual crash was not. So in our outcome, we are just experimenting in higher stiffness and higher head deceleration. Then we came up with the investigation, first numerical investigation simulation campaign involving pedestrian, different obviously kind of pedestrian. You can see the anthropometric data related to this pedestrian, an adult and old pedestrian, and a boy. And obviously, we vary also the type of the scooter, and we assume an adult driving this e-scooter. The simulation on which we perform a numerical reconstruction through these multi-body tools were mainly 5. A frontal impact, with an off-center, so there was an offset. The pedestrian and the e-scooter rider were not aligned. A lateral impact and a rear impact, aligned and not aligned with an offset. We obviously are interested in evaluating the HIC, the head impact criteria, that is the most relevant parameter that you can derive from an acceleration time history of the head, and is the most recognized parameter, synthetic parameter, since it is mainly related to the injury that the pedestrian or the scooter rider will undergo when following the impact. As you can see in the lower part of this slide, there is, for example, a typical relationship proposed by Prasa de Merz, expressing the probability of an aggregate injury scale 4, that is related to the death. It is related to the HIC level that is provided by the simulation. Here you can see the overall amount of the simulation performed, that obviously we are interested in developing injury function. And as you can see, there is a very high scattering of the provided by the simulation, because obviously we vary different impact condition. Following this not so satisfying scattering of the outcomes provided by the simulation, we came up with an idea of using a different explanatory variable in order to develop an injury function, and there we came up with this other formulation employing a simple physics-based explanatory variable, such as the kinetic energy, and we use these variables also to capture the behavior on offset impact by using the dimensionless overlap contact surface. And therefore, we came up with a more reduced scattering of the outcome of this simulation. A final comments on the outcomes and injury level suffered from the pedestrian and the e-scooter rider, that is mainly neglected in the current scientific literature. If we take into account the frontal and rear impact, as you can see, both pedestrian and e-scooter rider are encountering same probability and same injury level, by varying obviously the impact condition that we analyze. Whereas if we consider the side impact and the off-center impact, we notice a worsening of the HIC level for the rider compared with the pedestrian. And by analyzing the animation and the kinematic of this accident, we came up with the conclusion that this can be mainly due to the fact that the pedestrian following the impact will start a rotation, so most of the momentum transmitted by the impact will be converted in a rotational kinematic, and this will somehow raise the harms of the pedestrian. So the pedestrian, when it will fall on the ground, will be somehow protected by these arms, contrary to what is happening for the e-scooter rider. So, coming up to the conclusion, when a scooter collides with a pedestrian, much of the momentum is transferred to the pedestrian, leading to a longer launch distance and higher head-to-ground impact speed, resulting in a more serious potential head injury. Similarly, the results also show that the outcomes of the accident between scooters and pedestrians depends on the direction of impact. What happens to the rider head for the impact was also analyzed. It turned out that the HIC suffered from the rider is by no means negligible and highly depends on the angles of contact. To reduce the peak speed of the head in the contact with the ground, the use of an helmet is therefore strongly recommended. Impact analysis to be able to capture the complexity of this proposed accident scenario and provide a reliable estimate of possible outcomes. By extending the field of simulation scenario to be investigated, it's believed that it will be possible to achieve a better understanding of the problem, provide prediction function for pedestrian vulnerability. For the scenario will be essential to focus on the use of helmets and how they can maybe or may not reduce the HIC values. Thank you very much indeed, and I'm obviously here for some of your questions.
Thank you, Mauro. Mauro Coni has a question. Mauro? Mauro, switch on the microphone, please.
Okay, adesso mi sentite. Thank you, Francesca. Thank you, Mauro. It's very, very interesting. My presentation, I have some questions. First of all, MyDemo is the software that used to modelize the multi-body software. Is correct?
Yes. We compared this the results provided by two different software. The MyDemo that you already know, that is a very complex software because it takes a lot of time. Yes, it's very heavy. It's used by automotive industries. It's a state of the art. Okay. And we experiment the use of virtual crash. Obviously, I'm not doing any advertising of these tools, but we found this tool very, very powerful. And why we use virtual crash? Because we, as you already realize, we need to do lots of simulation that cannot be affordable with MyDemo. We also acquire MyDemo, and we are trying to obviously improve our calibration with some specific devoted models in MyDemo, but in our intention is to use virtual crash ones that will be calibrated on a regular basis in order to cover all the possible accident scenario. You have to think about that this is a very little part of the scenario that we are going to analyze, because we want to involve cyclists with pedestrians, cyclists with e-scooter rider, and so on. So it's a very high combination of scenario.
Mauro, I have another question, just a little bit. It's general question about our research is in the road, in the analyzed data, etc. But the automotive industry use this tool just to modify the cars in terms of stiffness, in terms of round shape, material, soft surface, just to reduce the impact versus the vulnerable user.
Yes, it's correct. There is a much more increasing interest of automotive materials in designing pedestrian-friendly vehicles, we may say.
There are branches.
So yes, but obviously you have to consider that the simulation, the collision between the vehicle and the e-scooter rider was mainly aimed at calibrating the virtual crash, not at investigating on obviously. But you are right. There is an increasing concern of the automotive industry. Just think about NCAP program, that is EuronCap. It is the main program devoting to the crash certification and the ranking. So it's increasing, but obviously we have also a vehicle fleet that is very different. So,
thank you, Mauro. Thank you so much.
Thank you so much.
Thank you, Mauro. Your research is very interesting and very actual for the examining the e-scooter. Mauro anticipated me for the question because I know that a lot of technicians use PC crash to reconstruct accidents, road accidents. But I think it is similar to virtual crash, and you
exactly, yes.
Okay, thank you so much. We can go on. I am the presenter of the next presentation. I am a researcher and assistant professor at the University of Cagliari. I am the author, co-author of over 90 scientific articles and over 2 textbooks on road geometry. My principal research interests include road safety, road construction, road design, mobility, sustainable materials, comfort in public transport. So I'm going to show you my presentation. . You can see it? Can you see it?
Yes, yes.
Thank you so much.
Right.
I'm going to talk about the analysis of a literature review on bus comfort on board. Before starting my presentation, I would like to thank my co-authors Mauro Coni, James Rombi, Benedetto Barabino, Roberto Ventura, and Nicoletta Rassu. During my presentation, I'm going to give you an introduction about this research project. I will discuss about its aim, and I will give you some detail about the methodology developed, and I will discuss you with the results and we have obtained so far. And I will try to draw some conclusions. Finally, I will give you some tips for future development of this research. It's known that public transportation is vital to creating more sustainable and smart cities. It reduces the carbon footprint by lowering private vehicle usage, thereby decreasing greenhouse gas emissions and improving air quality. Public transportation ensures equitable access to essential services and opportunities, promoting social inclusion and reducing barriers to economic and social participation. Additionally, a strong public transportation network stimulates economic growth by connecting people to job centers, educational institutions, healthcare, and commercial areas, attracting businesses, supporting local economies, and enhances property values. To encourage citizens to switch from private cars to public transit, municipalities and public transportation agencies must offer reliable, accessible, clean, healthy and comfortable transport services. OBCL, or as on-board bus comfort, is crucial for this shift, providing strategic benefits for public transportation companies. All that said, this paper reviews studies on OBCL to offer a thorough understanding of factors influencing passenger comfort, exploring various assessment methods and theories, incorporating research from multiple countries. An initial research on major databases such as Scopus, Web Science, and so on yielded approximately 15,000 documents published between 1980 and 2024. Then the studies were screened based on title and abstract. After removing duplicates, manuscripts concerning other disciplines as medicine, occupational medicine, ergonomic biology, etc., 70 eligible articles were included in this study. The selected studies dealt with the measurement of passenger comfort on buses by considering various attributes and subjective, objective, and mixed methodologies. So, starting from this observation, we decided to cluster studies in two distinct classifications. The first one categorized the studies according to the attributes, while the second on methodologies used for assess comfort. Hence, the initial phase of the study involved clustering the various studies based on the attributes used to evaluate comfort. 5 groups were identified. The initial group primarily comprises factors related to personal space that is available on board, including seating and personal space, passenger facilities, usability, passenger load, and load factor. The aspects related to climate conditions inside the bus, including temperature and cleanness, are encompassed in the second category. The third cluster includes studies on vibrations experienced by passengers and generally on physical and cinematic elements related to road conditions and traffic. The fourth category involves elements of the driver's driving behavior, covering longitudinal acceleration resulting from acceleration and braking maneuvers, lateral accelerations influenced by road curves, and vertical acceleration stemming from pavement irregularities. Lastly, the fifth group comprises several characteristics that address various comfort aspects simultaneously, as cleanliness, qualities of behavior, level crowding, vibration, space on board, cleanliness, and so on. Switching to the other classification, OBCL assessment employs 3 main approaches: subjective, objective, and combined methods. The subjective approach captures passengers' viewpoints on various attributes through customer satisfaction surveys. Objective measures certainly provide an embraced evaluation of BCL. Technical tools such as accelerometers, which offer unconditioned data, offer a means to monitor various comfort attributes. But the emerging approach to assess OBCL involves evaluation comfort aspects through both subjective and objective means. The analysis of the studies available in literature reveal both the advantages and disadvantages of subjective and objective analysis. Subjective analysis of BCL in public transportation are vital as they capture user perceptions, helping agencies enhance services to meet passenger expectations and attract more users. However, subjective ratings can be influenced by factors like socioeconomic background, personal comfort result, mood, past experience, and external conditions, such as fare heights. Thus, focusing solely on passenger views may be limiting, especially with non-representative samples. Objective measurements provide accurate and quantifiable data, ensuring consistent and repeatable assessment of comfort across various settings and conditions. This reliability allows for direct comparisons between different modes of transportation routes or vehicles, aiding transportation planners and operators in making well-informed decisions. Data can be acquired either under static conditions in the laboratory or directly on operational vehicles, with the latter offering a more accurate representation of real-world dynamics. However, while the objective measures are easy to acquire and evaluate, they may not fully capture comfort as they lack the subjective human experience. All that said, combining subjective assessment with objective data is essential for a comprehensive understanding of BCL in public transportation. This hybrid approach integrates quantifiable indicators and subjective sensation, providing a deep understanding of comfort levels. Recent studies show a notable shift towards this combined method. This figure suggests a framework for applying the mixed methodology. Summarizing the presentation, we can highlight that all the examined studies have presented intriguing attributes, systems, models, and methodologies for assessing OBCL. Furthermore, as comfort is a multidimensional construct, and these studies have shown how various approaches can measure it. The most suitable method for measuring OBCL appears to be that performs both subjective and objective measurements. However, despite OBCL measurement not being a new topic in the scientific community, some backlash persists, as limited sample size, a lack of algorithms to handle large amounts of data, and a failure to consider central acceleration component and user characteristics. With reference to the identified gaps, further and broader opportunities of investigation can be identified. Expanding the sample size in terms of monitored bus routes, the number and the characteristics of surveyed passengers, and measure the accelerations is necessary. Indeed, some authors study one or two routes, others interview only students, others measure only longitudinal transversal acceleration. Moreover, there is a lack of algorithms designed to handle large amounts and large volumes of data and data complexity. Working with limited data can introduce a significant level of empiricism, as it involves overly localized analysis and narrow conclusions. Consequently, the results may lack generalizability, and in contrast, using a huge amount of data for the measurements helps build the comfort scales that are more consolidated. Moreover, it is crucial to consider the vertical component of acceleration, as it has a significant impact on OBCL. Long-term exposure to high levels of vertical acceleration can cause discomfort and, in some cases, trauma, which can engender in physical problems and cause pain by affecting the general well-being of travelers both during and after travel. Vertical motion greatly influences stability, especially for standing passengers, also playing a crucial role in safety. Finally, the evaluation of driving style should differ based on the age of the passengers. Indeed, younger passengers may tolerate more dynamic driving styles since their physical performance allows them to react immediately to any abrupt change in direction or acceleration in braking. Whereas older passengers who may have health issues and mobility limitation often prefer smoother, gentler driving for increased comfort and safety. Therefore, if the driving style could adapt to the different needs of passengers, the well-being of all passengers could be ensured. Thank you for your attention. Have you got any questions? Mauro?
Yes, Francesca. Again, I must again compliment with this very interesting review of the literature on user comfort on transit, road transit. I'm just a curiosity. Throughout the research paper that you analyzed, that you looked through, is there some experimentation involving the use, for example, of smartphone as vibration sensor in order to have some quantitative data on vibrational comfort of user on battery? I was wondering, I mean, if there is some...
Yes, no, but your observation is correct. Numerous research use iPhone or smartphone even to collect the acceleration data using the GPS incorporated in this equipment. Or somebody use the iPhone, the smartphone, to collect the impression of passengers in the bus.
Perhaps considering some sort of reward for who is using this especially developed app, because obviously usually people is a little bit, resistant on the use of these survey tools, advanced survey tools. So I'm just thinking that perhaps there is some sort of reward mechanism that can, promote the use of this app that obviously are useful for us to collect relevant data and obviously should be widespread used in the population of transit. Okay, thank you very much indeed.
Thank you, Mauro. Thank you, everybody. Any more questions for me? No more? So we can go on. Our next and last speaker of this session is Aphrodite Pituli. Aphrodite is an architect engineering, holds a Master of Science degree in Urban and Spatial Planning from the National Technical University of Athens, and a Master of Science degree in Applied Geography and Spatial Planning, Spatial Policies and Development in Europe from Arokopio University of Athens. Nowadays, she is a PhD candidate at the Department of Urban and Regional Planning at National Sustainable Development, Technical University of Athens. Her research interests include spatial planning, urban resilience, and sustainable development with emphasis on port cities, waterfront development and management, and transportation and infrastructure system planning. Please, Aphrodite, the floor is yours.
Thank you. I will share my presentation. Just a minute. Can you see?
Yes.
Yes.
Okay. Hello, my name is Aphrodite Pitouli, and I will present a research project about international ports in medium-sized cities in Greece.
Aphrodite, we can see the full screen presentation. Try again to switch for okay. No. Full presentation, full screen. Sorry.
Now it's okay.
No.
Sorry. Just a minute.
The button on the right near to the zoom bar. It's not working.
I don't know.
Perhaps you need to repeat the sharing procedure and select
Okay.
the full screen mode and then select the full screen presentation mode.
Exactly. You have to select entire screen sharing. Then put the presentation in full screen mode.
Now?
Now it's perfect.
Yes.
Perfect.
It's okay. Okay, thank you. Well, in an area of network organization, technological revolution, and the threat of climate and energy crisis, the role of port cities is constantly changing. At the same time, current transport system conditions, the emergence of new intermodal hubs, and changes in ports industry are dramatically affecting port-city interaction, challenging the traditional mutually beneficial relationship between these two systems. In the context of the above assumptions, the article aims to formulate a multifactorial methodology for optimal understanding of port-city relations and their impact on port-city sustainability. Taking 5 Greek regional cities with an international port as a research area for the proposed methodology, the focus is on the monitoring of these cities using quantitative and qualitative criteria. The presentation follows the structure of the paper. After introducing the problem to be addressed, the presentation is organized as it follows: approach port-city relationships, description of the proposed methodology, presentation of the 5 port-city studied, examination of their importance as hubs in the European and Greek transport network, approach their dynamics as part of Hellenic urban network, focusing on 3 spatial levels: the port, the city, and the waterfront, presentation of the results of the comparative study of the selected Greek port cities, and of the crucial issues for further research. As port and city are two often contradictory but mutually reinforcing systems, assessing their relationship is a complex issue. The current literature has formulated many approaches to assess and measure port-city dynamics. Reviewing existing literature, the focus is on indicator-based approaches. The large number of indicators identified reflect the richness complexity of the issues related to port cities. In order to ensure optimal assessment of competitiveness and the sustainability of port cities, existing knowledge is used to organize the main themes of criteria and indicators that allow multifactorial monitoring of port-city relations and their impact on local and regional development. The aim is to create a pool of criteria and indicators that can be updated and enriched. This review led to formulating the proposed methodology and identifying the evaluation criteria. The proposed methodology aims to contribute to the scientific literature by proposing a framework from understanding and quantifying the dynamics of a port city from the perspective of port-city integration. Based on spatial criteria, the different aspects of this interaction and its contribution to local regional development are approached. Given the size and scope of ports and related supra-local activities developed in the wider urban environment of their cities, it is argued that the port-city relation should be studied at all scales. It is also emphasized that the dynamics of port cities need to be considered in a broader perspective, not only as a node in national transport network, but also as a part of national urban network. It is therefore emphasized that the assessment of the port-city relationship must be considered in three spatial units at the same time: the port, the city, and the waterfront. Based on the above assumptions, the article attempts a comparative study within a dynamic multi-level and multifactorial approach, incorporating spatial criteria in 6 thematic areas, namely centrality, demographic and socio-economic characteristics, accessibility and connectivity, natural cultural heritage, built environment, and supra-local infrastructure. At this stage, for each spatial unit, quantitative indicators are developed. These will be complemented by crucial issues such as port city waterfront governance, ownership status, port and spatial policies and planning approaches, stakeholders, and participatory planning. At a later stage, an attempt will be made to conduct a detailed study combining quantitative and qualitative indicators. According to Greek national ports policy, ports are divided into 4 groups: ports of international interest, ports of national importance, ports of major interest, and ports of local importance. In this research, particular attention is being paid to small and medium-sized cities in the Greek periphery, as the operation of a port of international importance is a complex, contradictory, and challenging planning issue. On the one hand, medium-sized cities face multiple pressures from port operation due to their limited size. On the other hand, they cannot always support the global role of their ports, mainly due to the lack of infrastructure. Furthermore, as the quality of the inland transport infrastructure is becoming one of the most critical factors in the competitiveness of ports, focusing on the mainland gives the chance to study a port city as a part of land transport networks. So, the proposed methodology was tested in the port cities below, from north to south: Alexandroupolis, Kavala, Igoumenitsa, and the larger and more developed port cities of Volos and Patras. The importance of Greece in the global and European network is crucial due to the geostrategic and geopolitical position of the country. Regarding the port network, the ranking of the 25 Greek ports in the Trans-European Transport Network recognizes their contribution to the European economy. Among the regional ports of international scope studied, Patras and Igoumenitsa are part of the national network, while Volos and Kavala are included in the extended network. Note that the port of Alexandroupolis is not included despite its strategic location. Regarding hinterland accessibility, it is considered by taking into account the geographical proximity of the port cities studied to the main national motorways and railways. Despite the strategic importance of port rail links for port development, most regional ports in Greece have no direct rail links. Finally, the use of complementary modes in maritime and air transport is of growing interest in transport planning. For Kavala, Volos, and Patras, their nearest airports are at a distance up to 40 kilometers, while the closest airport to the port of Igoumenitsa is further away. In order to assess the dynamics of the 5 ports, particular attention is paid to the analysis of data related to following criteria: port function services. Generally, the 5 port studies have a wide range of cargo and passenger handling services. Concerning container traffic, only the port of Volos had such services until 2017, while the port of Patras has been providing container handling service since 2018. Turnover profit. Alexandroupolis has the lowest rates, while Patras and Igoumenitsa recorded the highest turnover. Note that Igoumenitsa and Patras have had similar turnover rate since 2017. Traffic volume. In coastal shipping and passenger transport, the port of Igoumenitsa ranks first, followed by Kavala with Alexandroupolis in 5th place. Furthermore, Igoumenitsa is almost every year the #1 port in terms of traffic. Port governance. The privatization of the two major ports of Piraeus and Thessaloniki has influenced the Greek port system governance model and development prospects. In recent years, the privatization of the international ports of Alexandroupolis, Kavala, and Igoumenitsa has been at the center of the debate, but only Igoumenitsa has privatized. In order to assess the dynamics of their urban environment, particular attention is paid to the analysis of data related to the following criteria. Population. At the national level, Patras is the third largest city in Greece after Athens and Thessaloniki. Patras and Volos, followed by Alexandroupolis, Kavala, and Igoumenitsa, with significant population differences. Unemployment rate. Overall, Alexandroupolis has had the lowest unemployment rate in all the years examined. Patras had the highest unemployment rate in 2021 and 2011. Gross domestic product rate. The richest regional is Achaia, Patra, followed by Magnesia, Volos. GDP levels are similar in Evros, Alexandroupolis, and Kavala regional units. It's notable that Thesprotia, Igoumenitsa, was always last. Administrative role. Only Patras is a regional capital, NUTS 2. The others are seats of regional units, NUTS 3. Seat scope. At the political level, nowadays the assessment of urban dynamics and the classification of Greek cities is following the general framework for spatial planning and sustainable development. According to this, Patras, Volos, and Alexandroupolis are considered as major national poles. Kavala is a secondary national pole, and Igoumenitsa a limited national pole due to its small population, although its international port is a national western gateway. Supra-local infrastructures. At a scientific level, the assessment of urban dynamics generally confirms that the centrality of city depends not only on their population, but also on their geographical location, accessibility, and the presence of supra-local infrastructure. According to the study of Theodora and Loukakis, when population is disregarded and infrastructure of supra-local scope is weighted, the port city studies, with exception of Igoumenitsa, belong to the group of cities of major importance. The waterfront is a special category of space where port-city relationship becomes really visible, especially for small, medium-sized cities. Due to their scale, the waterfront is an important part of urban fabric and local identity. At these states, the study of urban waterfronts of the 5 port cities is based on the mapping of the dominant land use along the coastline and in the wider city. The next step, which is currently underway, is to focus on the city scale, aiming to identify coexistence problems and prioritize interventions. First results show that the current condition of waterfronts varies. This diversity of port city waterfronts is mainly determined by geomorphological, spatial, and developmental factors. This spatial study shows that, particularly along the waterfront, the proportion of port uses and green public space varies, but in most cases, port infrastructure is dominant. Igoumenitsa is an example of that. Based on the correlation analysis of the gravity and centrality in terms of international and national transport networks, we can classify the 5 port cities typologically into 3 groups. In the first group are Patras and Volos, the largest and the most dynamic port cities. In the second group are Alexandroupolis and Kavala. These ports are less dynamic, but have significant development potential. Finally, Igoumenitsa, despite the development potential due to its international port and centrality in the national road network and trans-European transport network, is placed in the third group, as it suffers from limited economic activity and lacking infrastructures. At the same time, the geomorphology of the city, urban development, and demands of the ports put increasing pressure on the natural, cultural, and man-made environment. The coexistence of these characteristics makes Igoumenitsa an interesting pilot case. The multifactorial and multi-level research shows that the dynamics of the port city studied are very different. As the majority of national investment seems to favor the more competitive metropolitan areas, dynamic monitoring at the port city level in the wider national and international context is crucial. In addition, as the port-city relationship is being redefined by the new requirements for sustainability resilience, the dominance of port factions on the waterfronts of Port City creates a wide range of constraints and difficulties. Today, port and cities should work closely together for effective green port and spatial policies which help port cities grow and increase their resilience. The interdependence of port and city in implementing policy comes at a time when the privatization of the regional ports of Alexandroupolis, Kavala, and Igoumenitsa is dominating the national debate. This raises further questions and dilemmas at the level of urban regional planning and local development in relation to the resilience of the port city. Thank you.
Thank you, Aphrodite. Are there any questions for Aphrodite? No questions? Thank you, Aphrodite. So, very interesting work. And we can finish our session. And that is all. And so I thank you, everybody, for attending this session.
Francesca, sorry to interrupt you. Can you confirm that the room will be the same in the next session that is scheduled?
We can ask to James because James is the chairman of the next session. James?
Actually, I don't know because I look up on the program because let's have a look.
It seems the same.
May I step in? It's the same room.
It's the same room. Okay.
I was going to ask you. Thank you very much for your.
My pleasure. Yeah, it's going to be room 6B if you want to look it up in the program.
Okay.
Room.
Session 6B.
Okay.
Okay.
So I guess see you in 25 minutes.
Okay. Thank you very much. Perfect.
Thank you very much.
Thank
I
you,
will
everybody.
stay. In this case, I will stay because just like you, I'm going, to present another paper, so I will not go out.
Perfect.
Okay.
See you later then.
Thank you.
Bye-bye.
Okay, see you later. Bye. Bye-bye.
Good morning.
Morning. Ciao Antonio.
Ciao Mauro, sono Marinella Giunta.
Ciao. Mi sarebbe piaciuto andare lì ad Antonio.
Ce la siamo perse questa.
Dear James.
Hello, good morning. Good morning, Giulio.
Hi, good morning.
We're back again.
So the live streaming is already on.
Okay.
So whenever you feel ready to start,
Yes.
you're free to go.
Okay. Just would like a few more minutes because there should be another chairman with me as well. I just
Of
wait.
course.
Okay.
Meanwhile, I will send you in private message the link to evaluate the session papers.
Okay.
So
thank you very much.
You can do it
Yes.
like right now while seeing the presentations or at the end.
Okay. Thank you very much.
You're welcome. Just 1 second. There you go. Can you confirm you see the link in chat?
I confirmed it. I received it. Thank you very much.
You're welcome. So yeah, I will mute myself. Whenever you're ready, you can directly start.
Okay.
Thank you.
Thank you.
Scusate, non riesco a capire come condividere la presentazione.
Sì, eccomi. Allora, il bottone è il terzo, quello accanto alla videocamera.
Ah, ok.
E la cosa da fare che conviene è mettere la presentazione, anzi, La cosa più semplice è condividere lo schermo intero.
Lo schermo intero è ok, con la presentazione già pronta. Perfetto.
Esatto, con lo schermo intero, se si ha uno schermo è la cosa più facile.
Sì, perfetto. Faccio così.
A posto.
Sorry, Giulio. I've seen that my co-chair, Antonio Comi, is online, but I don't know if he can see us because he's writing.
Oh, yeah. It might be related to his connection. If he doesn't have a good connection, he might see the streams interrupted, although they are online.
Okay. Because he's asking us to put the speakers on and switch on the video, but we have that already.
Yeah, I can see his writing. And I can also see his microphone is turned on. Antonio, could you please try to speak?
Antonio, we cannot hear you.
And not see you.
Also.
Either.
There might be a problem perhaps with the authorization to use microphone and camera on the browser.
Perhaps you should try to reconnect, Antonio.
Yes, that would be a good idea.
Yeah. I'm not sure he's hearing us as well, so I'm going to text in the chat.
Okay.
Thank you, Giulio. James, I cannot see the Vietnamese speaker.
No, in fact, I was just looking at, yes. Maybe because I've seen she's not, she would be by presence. Maybe she's going to connect further on. I don't know what's the procedure. Because she was the only one that wasn't doing it, she would be on present. And maybe she has to connect from another room inside the university there where they're taking the conference.
However, in the last session, Antonio was able to connect and to
Yes.
speak and
So that's even more strange.
Antonio, non so se hai un MacBook, perché sul mio ho dovuto...
Non è connesso ora.
Ah, ok. Giulio, non so se hai la possibilità di connetterti con lui in altra maniera, però io sul mio Mac ho dovuto attivare sulla sicurezza e privacy, autorizzare la registrazione dello schermo. Diversamente non mi faceva anche a me condividere o accedere alla stanza. Ieri ho fatto delle prove e il problema, ripeto, su Mac era questo.
Ok, interessante. Allora adesso appena provo a rientrare glielo dico. Non ho possibilità di connettermi direttamente con lui, però possiamo provare. Però se prima c'era riuscito, a meno che non abbia cambiato impostazioni. Fortunatamente abbiamo un po' di tempo perché ho visto che ci sono solo 4 paper in questa sessione.
Now?
Yes, Antonio, we can hear you.
Yes.
Yes.
Okay. I changed the browser and now but I don't know what happened with the camera.
Actually, we can see you twice. Are you connected with 2 browsers, perhaps?
Probably yes. One moment that I delete the other one. Okay. Now it should be okay.
Yeah, perhaps the camera is locked by another system, by another browser. I mean, are you using OBS?
I use OBS, but not now. Okay, we'll check one moment that I change the camera, and now.
Okay.
Oh yes.
Okay, it's
Okay.
okay. I don't know what happens, but okay. Sorry for this. I will go to for this time that we lost. I welcome to everybody, and it looks that now it is work. We have now 4 presentation in this session.
Yes.
Yeah, the first one is from our colleagues Mauro D'Apunzo, Giuseppe Cappelli, Sofia Nardoianni, Vittorio Nicolosi, and Michele De Guidi. Who is the presenter?
The presenter should be Giuseppe Cappelli. that if I can just a short introduction, Giuseppe Cappelli is ending a doctoral cycle on behalf of Italian Doctorate School in Sustainable Development and Climate Change. It is a very interesting efforts on renewing the doctorate cycle. And since he is the main contributor, other than one of the pillar, we may say, of my of the research team operating at the University of Cassino, I will be pleased to give Giuseppe the floor for the presentation. Thank you.
Okay, Giuseppe, do you have 20 minutes?
Yeah. Hello, everyone. I'm going to share the screen. Do you see the presentation?
Okay, we are able to see.
Okay. Hello, everyone. I'm Giuseppe Cappelli. I'm PhD student at University School for Advanced Studies in Pavia. But I'm actually working with Prof. Mauro D'Apuzzo at University of Cassino in Southern Lazio. In this session, I'm going to present this paper, and the title is Machine Learning Tools for Predicting the Outcome of Pedestrian Crashes, a case study in the metropolitan city of Rome. Pedestrian road accidents are influenced by a large number of features such as roadway, environment, crash scenarios, driver, vehicle characteristics, and also pedestrian-related characteristics such as age and gender. This factor all contributes with the severity of a pedestrian accident, and some way need to be assessed in a detailed way. The main problem with pedestrian road accident is that this large amount of features and this large amount of variables required strong tool to be analyzed. In this paper, we focus on the use of machine learning tools to forecast the outcome of pedestrian accident. The context in which these analyses are made is sustainable development. Sustainable development is that effort to find a compromise between the need of the present without compromising the future. So it is, how to say, a sustainable compromise between economy and profit. For example, we have to make profit, but with a sustainable way. Find a balance between environment and earth and our action, and also find a compromise between society and people with the aim to guarantee a good future for the next generation. So the main, my opinion, the main objectives of sustainable development are fair, doable, and also manageable. The main document that put the emphasis on sustainable development is the Agenda 30. This document, made by the UN General Assembly, find 17 objectives, that are somehow related. The theme of sustainable development fall under Objective 3, that is good health and well-being. Objective 9, that is industry innovation and infrastructure. And Objective 11, sustainable cities and communities. One of the most recent plan that give more attention to road safety in general and also to pedestrian crashes is the Decade of Action for Road Safety 2021-2030. And the UN General Assembly, with a resolution, declared this global plan with the aim to reduce road traffic deaths and injuries by at least by 50% in this period. The main topic of this document are represented by these three questions: what to do, how to do it, and who to do it. What to do is it's a good question, and the way to reduce road accidents in a global context is to improve safety of the road infrastructure, create more safe vehicles, and so improving all technologies related, improve also post-crash responses, because in small cities where the problem of traffic congestion is more relevant, post-crash response need to be very quick. And also promote multimodal transport in order to avoid private car use. But how to do it? The first framework that needs to be assessed is a legal framework in which all these actions need to be implemented. And for example, in urban areas, another way to do it is to reduce speed, for example, and also use technologies that are related to smart mobility, smart road, and so on. And as last question, what to do it? The main actor is the government and also private sector, UN agency, and also founders. But a main role is also played by civil society and also by university and researchers as you. Going to the case studies, we studied pedestrian accident in the metropolitan city of Rome from year 2014 to 2020. More than 10,000 pedestrian accidents are studied. And as we can see from the image and on the picture on the left, these accidents are geo-referentiated. The first step of this analysis that we have made is a descriptive analysis in order to understand that there is some variable related to pedestrian crashes that influence the most the outcome of this type of accident. As possible to see in the figure on the right, one of the main leading causes of crashes is the excessive speeds. There are also some trends that characterize pedestrian accident. As it's possible to see during a typical day, there are two peaks related to the noon, for example, and in the late afternoon. And so in some way it follows the classical traffic pattern that are used to see everywhere. And in addition to that, there are also a weekly pattern that, as you can see from this picture, is mainly constant during the weekdays, but decrease during the weekend days. Some other variable that influence the pedestrian crashes are road characteristics. For example, excessive speed, maneuvering, the vehicle that proceed regularly and so didn't see the pedestrian. And surprisingly, there is a large proportion of pedestrian hit for a non-direct accident, and that is a critical aspect to bear in mind. The majority of the pedestrian crashes happens on straight roads, and at the second place on intersection. Intersection, as you know, are one of the main problematic point in cities where there are a lot of overlapping with other traffic modes, and so it is a crucial aspect to bear in mind. Other road characteristics are the presence, for example, vertical and horizontal signposting. And as we can see, the majority of accidents happen when vertical and horizontal sign are present in a certain place. And also this accident happen when the road surface is mainly dry. These graphs, so as you can see, show that descriptive analysis are not so useful to understand which variable influenced most the road accident, but is way to study the frequency of some feature that happens during this phenomenon. And as you can see also in this slide, the majority of accident happens during when there is a sunny weather, and the vast majority of accidents are mainly when an accident occurs, they are mainly injured, and a small proportion of them died in 24 hours. In order to make a more reliable analysis and try to understand which variable influence pedestrian accident, we focused on try to study this phenomena with machine learning approach. The problem that we are here is a classification problem in which the dependent variable is not a numerical variable, but is a categorical variable. So the outcome are injured or dead. We tested several machine learning tools, such as linear discriminant analysis, quadratic discriminant analysis, k-nearest neighbor, artificial neural network, decision tree, random forest, and also support vector machine with several kernels, such as polynomial, radial, and linear kernel. So in this framework, we collect as first step data, and then we made a huge process for preprocessing this type of data, so cleaning and labeling these collected data. Then we split the data in a proportion of 70 and 30 in training set and test set. On training set, we made some analysis of feeder selection and evaluate the different model here described. With the test set, we tested this model, and in order to assess the prediction accuracy. If the prediction accuracy reached good values, we accepted this model. And anyway, in other cases, if this the accuracy of this model was not good, we chose another model and made again this type of analysis. In order to compare all these machine learning tools, we used the several metrics that are all based on the confusion matrix. The confusion matrix is a matrix that give the proportion of true positive, for example, and true negative. And so it makes some comparison with predicted values and real values. With this matrix, we are able to assess, to calculate some performance metrics such as the accuracy, recall, specificity, precision, F1 score, F2 score, and F3 score. And we use to make this comparison the F1 score that is a trade-off between accuracy and precision. And this matrix is commonly used in all machine learning approach. As we can see, the random forest has the highest F1 score compared to the other models. But in this case, we are also looking for the F3 score, because the F3 score give more importance to this prediction that to that prediction that are true negative. So the models see more that, for example, compared to the injury that happened in the reality. So with this F3 score, we are going to give much more attention to predict an elevated number of death. And this could be, for example, a good way to see this problem, because in a road accident, we want to predict also some false negative in order to be sure that we are predicting all the deaths that happens on urban roads. So in conclusion, we have seen that there is an increasing interest from General Assembly, for example, and from European Commission and worldwide government in study road accident, and also to assess road safety of city or of roads. We made in this study first a descriptive analysis of the pedestrian crashes, and then we applied some machine learning models to better study this phenomena. As future developments, we want to focus on, for example, random forest variable importance feature that allow us to understand in a more detailed way which are the main features that influence the outcome of the pedestrian crashes. And also to use this data set, for example, to create pedestrian crash model and so predict the probability related to pedestrian crashes on a real case study, for example, on the same case study that is here proposed. So thank you for the attention, and if there are any questions, I'm here.
Thank you very much, Giuseppe, for this presentation and for remain on time in the 20 minutes. Now we have time for 1-2 questions from the audience. Do you have any questions? Any request of clarification? Okay, please, Francesco. Okay.
Thank you, Mr. Chairman. And Giuseppe, perhaps it's my fault and I leave something, but could you please explain me better how you test the models? I notice in a slide where there is the framework, no?
Mhm.
And you show us the model, and in the other side, you write test the model. How you test the model?
Yeah. I share again my screen so I can show you
Yes,
the.
thank you.
Yeah, the
Okay.
okay. This is the general framework of this of a typical machine learning approach. We
Okay.
have a whole data set that in this case is provided by ISTAT. So give this that provide us this data. The whole data set was split in 2 samples. And so we create a training set and a test set. On the training set, for example, we try to test the random forest model. This random model forest was calibrated on this data in the training set. In order to assess how reliable is this model and how was able to describe the data that are provided by this dataset, we tested this model. So we use this calibrated model on a different dataset.
Okay.
That is the test set. So in this way, test is also could be translated also in validated. So we validate this model with this new test set, and we assess the prediction accuracy by comparing these performance metrics. So these performance metrics are evaluated not on the training set, but on the test set. The main problem of this machine learning approach is that they work well when they are calibrated, but sometimes they could give some problem when they are tested on a different dataset. So in this way, we have avoided this problem by evaluating this performance metric on the test set and not on the training set. So it's in this way the model is validated. These are the how to say, something that is similar to Pearson coefficient or to R square among 2 variables, for example.
Thank you so much,
Okay,
Giuseppe.
thank you, Giuseppe. Only, can you show again the slide 12, please? The slide away, in order to understand which are the dependent and independent variable in your model. What the tools are forecasting.
Yeah, in this data set we have a lot of variables, more than something like about 200 that are, as it's possible to see in this slide, roadway, environmental, related. Other variable gives some information on the crash scenario. So if there is a rear end collision, frontal or lateral collisions, some variable that give information about the driver, and so gender, age, psychophysical status, or for example the
Okay, then because if sorry if I interrupt you, but we have to go speedily because we are quite late. Only, but pay attention to don't use a lot and to have a quite rigid model that is good for the training test and the test, and so it's difficult to use for other cases. Because other things I would like to suggest to you to pay attention on some variables in order to consider that it's quite strange to see that in the weekend where the number of pedestrians could be higher is the number of accidents that involving the people are less, and you pay attention on the reason. Probably it's depend on the environment, built environment where the road accident happens, and they also to consider that is the aim of the travel zone. Thanks a lot for this interesting presentation and for having introduced us this very challenging field. Thanks so much. Then I would like to pass to the second of presentations. Is by the group from Cagliari, I think. Is from who is the presenter?
Yes, I will introduce Francesco Grazietti.
Okay.
I will introduce also, because I'm James Rombi, I'm also the co-chair of this session, and I'll say good morning to everybody. I just present Francesco. Francesco has a Master of Science in Civil Engineering and is at its second year of PhD here at the University of Cagliari. His topics are pavement, green pavement, and new solutions to evaluate consumption on the production of asphalt called warm asphalt, and so on. So, Francesco, the floor is yours. Please start the presentation.
Okay, hi everyone. Okay. Do you see the? Okay. Okay. Good day, everyone. My name is Francesco Grazietti. I'm PhD student at the University of Cagliari. The paper I'm going to present is titled Sustainability and Cost Efficiency in Asphalt Production, a comparison of mixing technology and the case of study in Sardinia, in Italy. This presentation will cover definitions, trends, and detailed cost analysis, and our conclusions. So the presentation will follow this outline, the introduction, definition of HMA, WMA, hot mix asphalt and warm mix asphalt, and trend.
Francesco is not moving on the presentation, and I think it's not a full screen as well.
Okay, now okay, I can continue.
No, it's not on full screen.
I will try again.
Please, Francesco, share the entire screen while you share the screen, not just one window.
Okay.
And then put the presentation in full screen mode.
maybe like this.
Oh, you've got a dual monitor setup?
Yeah.
So
I
first you have to start the presentation in full screen.
Okay.
And then start sharing. And while starting to share, you will see
All the
your full
screen.
screen presentation. And then you can select it.
Okay. Now?
No.
No.
So first start the full screen presentation with PowerPoint.
Okay.
Okay. Now stop sharing. Yes. Start the full screen presentation with PowerPoint. Then get back to sharing. And you will see among the options the full screen presentation.
Try again. Now?
Oh, yes.
Yes.
Okay, sorry. Okay. Okay, so the outline is this introduction, definition of HMA and WMA, so hot mix asphalt and warm mix asphalt, trends in asphalt production in Europe 2022, cost analysis to 2024 to produce HMA, WMA, with and without the use of RAP, recycled asphalt pavement, the case of study in Sardinia, and finally the conclusion. So, okay. Road networks are crucial for global economies, supporting the movement of goods and people. They come with significant environmental costs, including greenhouse gas emission and high energy consumption. Asphalt is widely used due to its versatility and strength, but also contributes to these environmental issues. This study focuses on sustainable practice such as warm mix asphalt and the use of RAP to reduce energy use and emissions. Specifically, we analyzed this technology in Sardinia to find the most cost-effective and sustainable construction methods. So we will define the different types of asphalt, and we discuss the advantage and disadvantage of this type. HMA is a traditional asphalt technology involving high temperature production, making it strong and durable for heavy traffic and adverse weather. However, it consumes significant energy and emits greenhouse gases. And despite its advantage in strength and cost effectiveness for large projects, the environmental impact is very important. Another type is the warm mix asphalt (WMA). WMA is produced at lower temperatures, reducing energy consumption and emission. It's better workability at low temperatures and work greater safety for workers. However, its physical and mechanical properties can be inferior to HMA, and the additives used may increase production costs. In addition to WMA, there is another sustainable practice involving the recycled asphalt pavement RAP. RAP involves reclaiming materials from existing pavements and incorporating it into new HMA or WMA mixture. This practice enhances environmental sustainability by reducing the demand for new materials, offers significant cost savings. However, the integration RAP presents challenge primarily due to the age and oxide bitumen it's contained. This aged bitumen increase the stiffness of the mixture, which can negatively affect the overall performance and workability of new asphalt. Therefore, careful consideration and optimization of RAP usage percentage are crucial to maintain the desired quality and durability of the pavement. Now explore the trends in Europe in asphalt production in 2022. The report I study was from European Asphalt Pavement Associations, a report by the European Asphalt offers a comprehensive analysis of the asphalt industry key statistics and trend across Europe for the year 2022. The report covers a wide range of aspects, including total production volumes, rates of reuse and recycling, various applications in different road layers, and the adoption of new technology innovation. While there was a slight decline in production compared to 2021, the figures remain close to the case average. Italy has experienced a large increase in asphalt production over the last 3 years, reaching 37.6 more or less million tons in 2022, just behind Germany and ahead of France. This statistic reveal in the report significant variation in asphalt production across European countries, reflecting difference in the road construction industry, in different infrastructure policies and recycling practice. In the last part of the report, the report talk about the percent of use the asphalt. Sorry, I lost my. The reuse in HMA, WMA, Alpha MA, and CMA of RAP. The figures show the percentage of behavior reclaimed asphalt we was reused. For the calculation of these values, only countries providing full data were considered. With this background, we can focus on the study in Sardinia. Okay. Okay, this study is evaluate the economic impact of using different asphalt types in Sardinia, considering 2024 material price. Sardinia's unique geographic context help us isolate variables like raw materials availability and climate. And we examine 4 asphalt mix to identify the most cost-effective and sustainable practice. The first one is HMN with virgin material. The second is HMN with 25% RAP. The third, the WMA with virgin material, and the fourth, WMA with 25% RAP. The analysis considers resource cost, energy savings from WMA, and land savings from reduced virgin material use, aligning the financial and environmental benefit of different mixing techniques. For the study, a new generation asphalt plant present in Sardinia was taken into consideration. This type asphalt plant ensure high quality control, but the problem is about that the plant has higher initial operating cost. Innovation like liquid LPG fuel, advanced burning system, photovoltaic supported canopies enhance energy efficiency and sustainability. Following this, we'll examine the mixed design components. We study some experimental mixed designs tested in Sardinia plant. Its design aims to optimize material use and recycling to reduce environmental impact. Components of the mixed design includes recycled asphalt pavement wrap used at 0% or 25% depending on the mixed design. Sand 0.4 millimeters constitutes 30%, 50% of the mix, provides the fine aggregate necessary for the mix structure. Sand for 8 millimeters make up 45%, 60% of the mix. Filler using about in amounts of 1%, 3%, ensure volumetric stability and feels voice in the mix. Bitumen represent 5%, 60% of the mix, acts as the binder, ensuring adhesion and cohesion in the asphalt. The last one, the additive specific to each mix time, HMA or WMA with or without wrap, enhances the properties and the reduced production temperature, optimizing the mix for sustainable and performance. The additives considered are three. One additive for WMA no wrap with no wrap, one for HMA with wrap, and the last one for WMA with wrap. The goal the goals are energy savings, lower production compaction temperature, reduce energy consumption, emission reduction, reduce temperature and efficient additives, lower greenhouse gas emission, and the last one, material recycling, incorporating wrap promotes recycling, reducing the need for virgin material and minimizing environmental impact. So the cost analysis compares expenses for different mix design we try. Bitumen cost significant impact over expenses, while additive to increasing initial cost, improving mix performance and efficiency. Energy saving from lower production temperatures also contribute to reduction. Starting with the wrap component, there's no cost for mixture without wrap, but for those with wrap, the cost is €1.63 per unit. Next, consider the sand. The final sand is cost €7.05 more or less, and for HMA. For WMA, slightly cheaper. In the end, we can see that the euro per ton for the mixed design HMA without wrap is €51 points more or less. The WMA is cheaper, but not a lot. The HMA with wrap is €43.05, and the last one €43.60. Okay, the study also examined the energy efficiency and the environmental impact of the different mix design. Warm mix asphalt technology demonstrates savings compared to hot mix asphalt. During the cold season, HMA has an average gas consumption of 3.7 normal cubic meter per ton, while WMA reduces this to 3.1 normal cubic meter per ton, leading to cost savings and environmental benefits. In conclusion, warm mix asphalt pavements reduce energy consumption, but require a balance between economic management due to costly additive and mechanical performance. The addition of recycled asphalt pavements wrap in mixed design significantly reduce cost and the carbon footprint, but it also must meet the required mechanical performance during the design phase. This results support global strategies for road infrastructure that emphasize environmental compatibility with economic feasibility, aligning with the principles of the circular economy. Thank you for the attention. Sorry for the problem before.
Dear James, okay, thanks so much for this interesting presentation, Francesco. And now I would like to ask some, if there are some questions from the. Okay, please, Mauro.
Yes, thank you, Francesco, for your very interesting presentation. Just a brief thought on this very interesting experience that you presented us. I was wondering if is there a problem with the procurement procedure that perhaps should be rethinked or redesigned in order to introduce some sort of a pay factor criteria that can reward roadworks enterprises that are willing to use these new mixes that are, able to reduce carbon footprint and so on. I mean, obviously, you demonstrate that there are different ways to reduce environmental impact. But I'm wondering if the roadworkers enterprises should be aware and should be, stimulated to use this new approach. And this perhaps could be obtained also by modifying procurement procedure. And unfortunately, in Italian regulation, you don't have so much room for this kind of modification. I just want to have your idea on this subject.
Yes, the problem in Italy, I think, is the regulation, because I told about test. All these mixed design were test. So the difficult for the agencies in this case is to try the materials on the road, on the pavement, and after try to look how this mixed design perform, because in the cost are of this material respect of the traditional HMA is good, but the problem is the mechanical perform with our regulation, and also the regulation and the percent of wrap we can use inside the mix. I think for the agency the problem is this, but the research need to search the I don't know, the a position between the agency and the market and the cost. I don't know.
Thank you very much, Francesco.
Thank you.
Can you hear me? Can you hear me?
Yes.
Okay. We are in the physical room, so
sorry, because I had the microphone closer. Thank you, Giuseppe Francesco, for this. And now we have the second part of this presentation and of this session. And I would like to ask James if he can lead this second part.
Okay.
Okay, thanks so much.
Thank you very much, Antonio. Thank you. So we managed this second part of this section. Now I guess we got a presentation directly from the where is taking part. Is not online. Is it in presence there? So whenever you're ready, you can have the floor. The next presentation is evaluation of reinforcement learning algorithm applied to an autonomous car model for educational purposes.
Okay, sorry, just one moment. We are fixing the audio because it's too noisy in this room. Can you hear us?
Yes, we can hear you.
Okay, just a moment and we start. Thank you.
Perhaps, Francesco, you should unshare your screen.
Sorry, sorry again.
Okay. Can you see the screen?
Yes, we can see it nice and clear.
Excellent. Okay, please. Okay. You can move. You can hide here. And you can move. If you want. Okay. 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 Thank you. Hello everyone. My name is Hao, and today I represent my team to present our research on evaluation of reinforcement learning algorithms applied to an autonomous car model for education purpose. The our research have been published by Bùi Minh Quang, Linh Học, and our partner at VNU University of Engineering and Technology, Faculty of Information Technology, and Hanoi University of Science and Technology. Our report have five sessions. Follow the first introduction. Session 2 describe the theoretical foundation of reinforcement learning and how it is applied into autonomous car. The third describes the implementation of an reinforcement learning algorithm. The session 4 I discussed about the experiment and preliminary result, and session 5 serves as a conclusion, summarizing the finding. Yes. Currently, autonomous cars are intensively studied by many institutions and companies. The problem related to autonomous vehicles have gained significant attention recently. Although the concept were first proposed quite a long time ago, in 1925 by Houdina, they used the term a radio controller car to describe the concept of car controlled by radio waves. But it was not successful as successful as expected. Later on in 1969 by M. Carty. M. Carty introduced the concept of autonomy and named it robot chauffeur. In 2003, Toyota introduced the Prius hybrid, which uses sensor and cameras module that perform well in autonomous parking. In 2017, GM Super Cruise were introduced, providing autonomic support with features such as braking, speed control, and lane changing. In 2021, Google launched Waymo, a fully autonomous car which requires no human interaction. However, the evolution of reinforcement learning algorithm in autonomous vehicles face many major challenges. A special of concern is the cost of manufacturing the vehicle and the cost of integrating technology into a car that can sense the environment and the car can perform certain level of autonomy. So this paper presents the process of developing an autonomous vehicle model for education purpose that can self-optimize its decision-making option based on a reinforcement learning algorithm, such as quick learning. The algorithm has trained autonomous car to avoid collisions. The the first variation concept of methodology that is agent-based modeling. One of the most commonly recognized definition of agent is that of Russell and Norvin, in which the author define an agent as a flexible and autonomous entity capable of recognizing the environment through its sensor connected to it and influencing that environment through actuators. The concept of environment is defined as anything outside the agent or the entire universe. The relationship at the picture, the relationship between agent and environment is defined, and the environment are described through three core components: state, reward, and action. The figure also illustrates the state transformation of the environment under the behavior of an agent in the form of Markov decision process. The next is I talk about the reinforcement learning context. The main concept of reinforcement learning are states, action, reward, and policy. Here are the principal elements in any reinforcement learning algorithm. The first one, we have agent, which is the decision maker that had to be trained to make the right decision to achieve our objective. The second is the decision maker is responsible for observing the environment and understanding the current state for the environment. A combination of observation make up the current state, and different action can be taken based on what that state is. The third is the decision maker is responsible for taking actions based on the policy that is had learned. The objective of the agent is to maximize its rewards. Every action that an agent takes in a particular state has an associated reward or punishment. So in short, after the training decision maker to take actions to maximize rewards in an uncertain environment. Reinforcement learning is commonly applied in various domains such as autonomous system, finance, game playing, and robotics. The last is about Markov decision process. The environment in which a reinforcement learning agent operates is critical, and we need to model this environment. Commonly, environments are complex, and modeling environment is hard, which means we need to use some kind of simplification technique. The appearance of Markov decision process help us to solve the problem. Why does the Markov decision process matters? The Markov decision process it greatly simplifies exploration of environment. With the Markov decision process, best action, reward, or fraud state can be memorized. Cached. this allows us to model even very complex environment. And oh sorry, I forgot it. And the next session is about implementation the reformer learning agent and deploy it into a miniature car model. We are building a miniature car model with some some components in the picture. The picture shows the main component for the autonomous car model. We use the Raspberry Pi. It is a microcomputer designed to promote programming education and electronic projects. We use ultrasonic sensor, one of the most popular sensor in robotic project to get the state of the environment. We have motor driver, expansion board, and power supply for miniature car. And this is design of the shell for the autonomous car model. For reforming algorithm, we implement the q-learning algorithm. For the q-learning method, we update formula, the follow formula, and to implement this, first we need to set up initial query table with states are rows and actions are columns. We set up policy for rewards associated with actions, and as the formula, you can see for every time step in the changing process, I will update the query table with the reward that associated with the action of the agent. In the formula, there appear of learning rate alpha. It defines the size of the movement away from current state when exploring. It also contains discount factor. It defines how much to downweigh uncertain future rewards. And the we implement our algorithm on a simulation, and we deploy it into a miniature car model. And the next session is about experiment and preliminary result. The figure 4 shows the result of reward function when we adjusting the learning rate parameter. When learning rate equal to 0.5, it is observed that the learning rate is too high, leading to rapid updates of the key table. When reducing the learning rate to 0.1, the model exhibits stability during training and achieve higher and more accurate average performance. The figure 5 shows the result of the reward function when adjusting the discount factor parameter. When setting the value of the discount factor to 0.9, the agent focuses on rewards and short-term goals. When the discount factor is 0.975, the agent focuses on the long-term goal, which leads to the ability to learn, and the performance of the model may decrease over time. The figure 6 shows the result of the reward function when adjusting the decay rate parameter. With a decay rate of 0.05, the model learns faster and the car runs better during the learning process. With a decay rate of 0.05, the results show more compatibility and balance between exploration and exploitation decisions, giving accurate results and that gradually increase over time. There are some conclusions. The preliminary results show that the quick-learning algorithm is successful in building a cell training technique to adapt specific requirements. The quick-learning algorithm, combined with a reasonable mechanical and electronic design, the car can run smoothly and avoid obstacles on the road based on the distance value returned from the ultrasonic sensor. This research is just a preliminary step. The autonomous vehicle model applying the quick-learning algorithm serves as a solid foundation for future ideas. There are some references I mentioned in the slide. Thank you for listening, and thank you for listening. Did you have any question?
Thank you very much for the presentation. And are there any questions? If there aren't any questions, I think we can follow with the last presentation of this session. Is the presenter of this session online? We'll be presenting.
We can stop the screen sharing. Yes.
We will be presenting. Marinella, are you presenting this the research?
Yes.
The next paper is entitled Framework for Life Cycle Railway Sustainability Assessment, a methodological approach based on advanced methods and tools. Please, Marinella, the floor is yours.
Thank you very much. I'm sharing my presentation. Thank you, Mr. Chairman. Good afternoon, everyone. Good morning to Italian and European people participating in this session. I'm Marinella Giunta from University Mediterranean of Reggio Calabria, and today I present a paper aimed at delivering a framework of methods and tools in use for the assessment of the sustainability railway field, and proposing an integrated method for comprehensive evaluation and of rail track sustainability. Co-author of this paper is the Professor Giovanni Leonardi, my colleague. Here the agenda of my presentation: background, objective of the study, framework for the assessment of the sustainability, methods and tools. Then I refer about a case study referred to the comparison of two track systems, discussion of results, and finally the conclusions. Climate change arising by the increasing of greenhouse gas emissions emphasizes the urgent need for countries to prioritize the sustainable transportation infrastructure as a crucial sector for climate action. This is required also by Agenda 2030 Goal 13. Indeed, transport produces almost a quarter of Europe's greenhouse gas emission, in addition to being the main cause of air pollution in the cities. The aspect of the climate change must be accounted together with the increasing awareness of the need of sustainable management and conservation of the resources. In this sense, apply the principle of circular economy and use energy from renewable sources are nowadays essential elements in the design, construction, and management of transport infrastructure. The 8% of global passengers and freight demand are satisfied by the rails, which are responsible for only the 4% of the total emissions generated by the world transportation system, and the 70% rely to the road transport. In this sense, it can affirm that rail is the main pillar of the transformative climate action in transport sector, being the fastest and most cost-efficient way to decarbonize the people's daily mobility and logistic chains. Here, because the railway corridors improvement and development are the most appropriate answer to the need of providing sustainable transportation of people and goods. But it's important to having in mind that the expansion, the improvement of railway corridors must be considered in the improvement of corridors. Then the sustainability must be considered as a pivot around which revolve the conception, construction, and management phases. The track is one of the fundamental components of the rails, and the objective of sustainability of the track calls for the adoption of solutions and materials able to improve more and more the environmental performances. In the light of these premises, the objective of this work is twofold. To provide a framework of methods for the assessment of the rail track sustainability and demonstrate the suitability of the application of integrated approaches in the comparison of two track systems. When we talk about track systems, reference is made to that two main systems, the ballasted track and the ballastless or slab track. The ballasted track consists from the top to down of rails, sleepers, fastenings, which fix the rails to the sleepers, ensuring the gauge, namely the right distance between the rails, the ballast and the subballast. The ballastless or slab track, as the same word says, misses of ballast, and the rails are fixed to a slab made with concrete, which has the function of support and load distribution. Materials, components of the two track systems, materials used, and function and maintenance activities needed during the service life are reported in this table. In order to assess the sustainability of rail track, is fundamental to consider the life cycle. Life cycle, according to the ISO standard, consists of 4 stages, namely the production stage, which encompasses 3 modules: the raw materials extraction, in this case steel, aggregate, cement, water; the transport of raw materials to the manufacturing factory, and the manufacturing of the components, of the track components. The construction process is divided in transport of component to the construction, from the factory to the construction site, and the construction installation process. Use stage include use, maintenance, repair, replacement, refurbishment, and also operational use of energy and water. And finally, the end of life stage considers the construction, demolition, the transport, the waste processing, and the disposal. It's important to consider the life cycle of the track, because at any stage of the life, the decision-making process can affect the sustainability. More specifically, in the design and construction stages, the selection of the more appropriate track system, ballasted or ballastless, in function of the level of traffic, axle loads, train speeds, the type of materials and components, their supply mode, and the hauling distance, as well as the construction schedule, are elements which greatly affect the sustainability. In service life, maintenance strategies, materials, equipment, and machinery used for maintenance activities are important elements to consider. And in the use stage, is important to forecast the degradation of the structural and geometric quality of the track, and forecast also the maintenance intervention needed to ensure efficiency, safety, regularity of the rail service. Track degradation models are very useful to this aim. Track degradation models can be mechanistic, empirical, hybrid, or based on the method of artificial intelligence. Regarding the end of life, the reuse, recycling of the dismantled materials or the landfill produce different effects regarding the sustainability. Life cycle information allows to perform the life cycle sustainability assessment, which is based on the consideration of the 3 main pillars: the environmental pillar, the economic pillar, and the social pillar. As for the environmental aspect, the life cycle assessment is a procedure able to evaluate and quantify the impact produced by a product or services. And the LCA study consists of 4 stages: goal and scope definition, inventory analysis, impact assessment, and interpretation of data. As for life cycle cost, according to the definition provided by the ISO, it can be defined as the cost of an asset or its part through its life cycle while fulfilling the performance requirements. The life cycle cost analysis permits to compare economic performance of different alternatives. In this case, the ballasted track and the slab track, and the trend of the cost during the lifespan allow to carry out complete evaluations for identifying the most convenient alternative solution. It's important to highlight that the expenditure happen at different time of the life, so we can distinguish among the initial costs, usually corresponding to the construction cost, and the recurrent cost due to the maintenance and the renewal activities. Future costs can be expressed at today equivalent by means the discounting process, and then using an appropriate discount rate. Regarding the social life cycle assessment, this is a method able to assess the social and sociological aspects of a product and the potential positive as well as negative impact along the lifespan. In this slide is reported the UNEP, the procedure, the methodology proposed by the UNEP guidelines for identify the inventory data to perform the social life cycle assessment. Methodology starting from the identification of the stakeholders, namely workers, local community, society, the impact categories, in example, human rights, working condition, subcategories, inventory indicators, inventory data. It's important to highlight that the social sustainability of track is less represented in the research because of the complexity of quantification, interpretation of the impact. Synthesis of method and tools for the sustainability assessment of the rail track based on life cycle information is reported reported in this slide where you can see the LCA, the LCCA, the social LCA already discussed, the artificial intelligence useful for the forecasting of degradation process of track, and the circular economy that which is an important aspect, considering the great amount of materials used for construction and maintenance of track. To prove the potentials of the discussed methods, an integrative approach, life cycle cost, life cycle assessment, is applied to a case study referred to the comparison of the two track systems, the ballasted track and the slab track. As you can see in the table, for each track component is specified the type of component, the dimension, and the service life. According to the proposed integrated method, the life cycle costs for each track solution encompass company costs, costs due to the construction, maintenance, renewal, the user cost produced by the mainly referred to the delays produced by the maintenance renewal activities, and the environmental costs are considered as the cost of the carbon dioxide emissions and calculated using the life cycle assessment. The appraisal of the two alternatives is referred to a double track line 1 kilometer long. figure in the left side of the slide shows the trend of the total cost for the two alternatives. The ballasted continuous line and the slab track dashed line in a lifespan comprised between 0 and 16 years. It's worthy to note that at the end of construction, corresponding to the year 0, the slab track exhibits total cost about 1.5 higher than that of the ballasted track. This is a result in line with the literature. At year 0, the total cost consists of the construction cost and the environmental cost, while the user cost is null. Break-even is observed at about 26 years. After that, the total cost of slab track remain lower, albeit slightly, than that the ballasted one. For a better understanding of the sustainability of the two solutions, company cost, user cost, environmental costs have been calculated at 3 different time frames, 0, 30, and 60 years. As you can see, the company cost for construction, management, maintenance, and renewal are lower at construction stage and the short period for the ballasted track, while reach a value which is 1.15 times higher than that of the slab track in the long term. And this is because the high frequency of maintenance activities needed in the ballasted system. The user cost for ballasted track lower in the short period, become higher in the long period, and reach a value 2.3 times higher than that of the slab track. The environmental cost exhibit a reverse trend for the two solutions. This is due to the carbon footprint of the cement concrete, and that is very high if compared with the ballast. This makes the slab track less preferable from the environmental standpoint. However, the integrated evaluation of the environmental and economical aspects allows to do more complete consideration and evaluation in the decision-making process of the selection of the more suitable solution. In conclusion, a framework of methods and tools used for the assessment of the sustainability of the track have been presented, and the proposed methods have a great potential to support decision-making process, as demonstrated by the case study carried out and referred to the comparison of ballasted and ballastless track systems. Integrating technical environmental issues is sometimes a tricky exercise, especially because several data are requested to do reliable appraisals, but it remains the right way for a comprehensive, complete comparison among different alternatives. This study was carried out within the MOST, the Sustainable Mobility National Research Center, which received funding from the European Union, Next Generation EU. This study belongs to the SPOC for rail. Thank you for your attention.
Thank you very much, Marinella, for the excellent presentation and very interesting. Are there any questions, please? I guess there are any questions, and so we've finished with all the presentations to this session. So I thank you very much for the very good session with many topics that we will learn about, and I would like to say thank you to all of you, and maybe see you next year. I would like to give the Antonio, are you connected?
Yes, I am connected.
Okay. If you would like to say just 2 words to say.
Okay, thank you to everybody for this interesting presentation. I think that we had 4 very interesting presentations, also for our PhD students. Thank you very much. Congratulations to everybody for this interesting research that you are developing. Thanks so much, and I hope to continue this conference and enjoy for who is in Hanoi.
Yes. Bye. Thank you very much.
Bye bye. Bye bye.
Dear James, dear Antonio,
yes.
Can I have just one word for you?
Yes, of course.
So, as I sent you in a private message, could you please complete the evaluation forms for the papers in this session?
Yes.
It's important for the, for the best papers awards.
Okay.
So, at your earliest convenience, at the link I sent you, please evaluate the papers.
Okay.
Thank you very much for.
Thank you very
for
much
chairing the session.
Thank you.
Thank you. You welcome. Bye. Bye.
Thank you. Bye.
Bye bye.
Bye bye. Bye bye.